Okay. Thank you all for joining. We really appreciate it. I want to thank Logan from the Emergency Operations Center for helping set this up with the Colorado State University with their meteorology and hurricane team. So Phil, I'm going to turn it right over to you and we should be good to go.
Yeah, thanks so much. I will share my screen and just confirm for me that you can see it.
Yes, we can.
Awesome. All right. So thanks so much for having me today. I'm going to be providing you a discussion of our hurricane forecast that our group at Colorado State University put out this year in early April, about a month ago. And I'll talk a little bit about what has stayed the same and what may have changed since that point. And so our group at Colorado State, we've been doing seasonal hurricane forecasts all the way back to 1984. So this is our 39th year of doing seasonal hurricane predictions. And so before we kind of dive in and look at the 2022 season, I wanted to start by kind of providing a little bit of a discussion as to how we even do these seasonal hurricane forecasts. And I like to start with a couple of quotes from one of the greatest philosophers of all time, the great Yankee catcher Yogi Berra, who once stated that it's tough to make predictions, especially about the future. And certainly it's that way for hurricane seasons, it's that way for sporting events. Predicting the future is hard. However, when it comes to seasonal hurricane prediction, I think another statement by Yogi Berra is really prescient, and that is that you can see a lot by looking. Basically, by going back into the past and looking at historical weather and climate patterns, it can tell us a lot about how active the upcoming season is likely to be. Hurricanes are not random. They do respond to the overall large-scale atmospheric and oceanic environment. And so, for example, we have hurricane data going back all the way to the mid-19th century, but it's been pretty reliable since about 1950. We also have reasonably good global data on things such as water temperatures, pressures, and wind patterns going back 40, 50, 60, even as far back as 70 years. So here's a plot showing the sea surface temperatures during August to October, which are the peak 3 months of the Atlantic hurricane season, for the 10 most active hurricane seasons minus the 10 least active hurricane seasons since 1950. And if we look at this plot, a couple of things to draw your attention to, you see yellows and greens in the Atlantic. That is indicative of warmer water in active seasons. And that makes sense. Hurricanes live off of warm ocean water. So more of that warm ocean water means more fuel for developing tropical cyclones and hurricanes. It also tends to be associated with lower pressures and a more unstable atmosphere, which help fuel the thunderstorms that are the building blocks of the hurricanes. If we look in the eastern and central tropical Pacific, we see a big cold blob. That's indicative of La Nina conditions. La Nina is basically the opposite of El Nino, which is warmer than normal waters in that same region. And it was really that discovery of El Nino and how it impacted Atlantic hurricanes that got the forecast at CSU going back in 1984. These forecasts were founded by Dr. Bill Gray. And one of the things that he noted was that when you have El Nino, you have fewer hurricanes in the Atlantic. And then the challenge was trying to understand why something going on in the Pacific Ocean would impact hurricanes in the Atlantic Oceans thousands of miles away. So if we think about the Atlantic Ocean, in the tropical Atlantic, winds near the surface of the ocean blow out of the east. These are the trade winds. And upper levels, so say 20 to 30,000 feet, these winds tend to blow out of the west. So you have kind of basically what's known as a shear or vertical wind shear, so that you have a change in wind direction and speed with height in the atmosphere. And too much shear is detrimental for hurricanes. It tends to tilt the hurricane circulation and disrupt it. In an El Nino event, we tend to have more of this shear. We get really strong winds out of the west at upper levels that tend to tear apart hurricanes as they're trying to develop and to intensify. Alternatively, when we have La Nina conditions, we tend to have weaker levels of that vertical wind shear and overall more active Atlantic hurricane seasons. So we use a lot of these historical relationships in our seasonal forecasts. So here is the forecast for the 2022 season. We call for a total of 19 storms. So these are systems named by the National Hurricane Center, winds of 39 miles per hour or greater. Of those 19, 9 becoming hurricanes, and of those 9, 4 becoming major category 3, 4, 5 hurricanes on the Saffir-Simpson hurricane wind scale. And so these category 3, 4, 5 hurricanes, winds of 111 miles per hour, even though they only make up about 20% of all the storms that form in the Atlantic on an average season, they do about 80 to 85% of the normalized damage. So the damage when you adjust for inflation, population, and wealth. We also forecast a couple of integrated indices that kind of give you an overall better idea of exactly how busy the hurricane season is. All of these values are above normal for the 2022 Atlantic hurricane season. And so one of the big reasons why is, if you look at this plot, here are current sea surface temperature anomalies or differences from the long-term average. So here reds indicate warmer than normal, blues indicate colder than normal. And if we look at the eastern and central tropical Pacific and the area highlighted by the blue rectangle, we can see a lot of blues and greens indicative of colder than normal water in the eastern and central tropical Pacific, basically what we expect and what is associated with a La Nina event. We've had La Nina in place since the latter part of the 2021. And again, when we have La Nina, it tends to be associated with more active Atlantic hurricane seasons through reductions in vertical wind shear. But just because we have La Nina now is not a guarantee that we're going to have La Nina for the peak of the Atlantic hurricane season. So what we then wanted to do was look and see what the various forecast models are calling for the 2022 hurricane season. And so NOAA, the National Oceanic and Atmospheric Administration, what they do is every month they put out probabilities of El Nino, La Nina, as well as neutral conditions, which are basically water temperatures near average. And what they've done for the April forecast is they're generally calling for a fairly low risk of La Nina or El Nino for the peak of the season. If we zoom in on the Pacific, we can see the water temperatures right now are pretty cold. And that blue rectangle is a region that's known as a Nino 3.4 region. It's basically typical government, not necessarily the most exciting nomenclature, but basically that's a box that is, or a rectangle that is monitored by NOAA. When the water temperatures there are 0.5 degrees Celsius or more colder than normal, you declare a La Nina. 0.5 degree Celsius or more warmer than normal, you declare an El Nino. So these are only talking temperature differences of say 1-2 degrees Fahrenheit. But these small temperature changes in the tropics can then have big changes in how the atmosphere then responds. So if we look at the latest forecast from the US government, they do a probabilistic forecast. So you can see for August through October, as highlighted by that black arrow, they give about a 50% chance of La Nina, a less than 10% chance of El Nino, and about a 40% chance of neutral conditions, which again means neither El Nino nor La Nina. If we get neutral conditions, then what happens in the Atlantic becomes even more critical because you can have very quiet seasons in neutral years, or you can have very busy seasons in neutral years. And what happens in the Atlantic then becomes even more critical. So here are the latest forecasts from a whole pile of different weather models. So there's a whole lot of different weather models that forecast El Nino versus La Nina. And basically, not going to go through all these acronyms. What I wanted to basically highlight is that pretty much every model, except for one, is calling for is calling for either neutral or La Nina conditions for the peak of the Atlantic hurricane season. So now stepping away from the Pacific and focusing on the Atlantic, here are the current water temperatures in the Atlantic. Here again, blues indicate colder than normal, reds indicate warmer than normal. And so you can see water temperatures in the tropical Atlantic are near average, but in the subtropical Atlantic, so a little farther north, in general, they are above normal. And so during the peak of the season, it's really critical what's going on in the tropical Atlantic, because obviously that's where the hurricanes are. But if we look in the prior to the peak of the season, we actually really want to pay attention to what is going on in the subtropical Atlantic. And the reason why that's the case is because when you get warm waters there, it tends to then force lower pressures. And when the atmospheric pressure drops, it tends to then weaken the winds. And when you get those, or it tends to weaken the winds around what's known as a subtropical area, which typically has high pressure. Those weaker winds cause less mixing and churning up of the ocean surface, which then leads to warming of the tropical Atlantic for the peak of the Atlantic hurricane season. And so if we look historically at which regions in the Atlantic typically correlate with busy Atlantic hurricane seasons, here's a plot showing this for the month of May. Basically, you want, if you're looking for a busy season, you want a lot of warmth, especially in the eastern Atlantic. And so the current sea surface temperature pattern, you have In the tropics, it's still just near average. In the subtropics and heading even farther north, the waters are warmer. So overall, certainly not a slam dunk for an above normal season from looking at the Atlantic, but overall, the Eastern Atlantic does tend to be at least a little bit warmer than normal right now. We can also look at what climate models are projecting for the peak of the season. So this is a forecast from the European Center. This one actually just hit the presses a couple hours ago. And so you can see the forecast for the Atlantic in general is calling for near average water temperatures, a little bit above normal, especially in the subtropical Atlantic. But the model is generally projecting that we're likely to have either cool neutral, so slightly cooler than normal, but not quite up to La Nina, or more even likely La Nina conditions for the peak of the Atlantic hurricane season. This model, in addition to forecasting sea surface temperatures and things along those lines, will also forecast the actual number of hurricanes. The model will actually spin up hurricanes. And so the model overall is calling for a little bit above normal. The average of its forecast calling for 8 hurricanes. The model is calling for 8 hurricanes. The average season has about 7. Our forecast is for 9. So in general, in line with what is being forecast by the ECMWF, which is the European Center for Medium Range Weather Forecast, which is a climate modeling group that is based in the UK. We can also look at forecasts from NOAA. This is the Climate Forecast System model. And so this model is also calling for cooler than normal water in the Eastern and Central Tropical Pacific. This model is even more aggressive at calling for La Nina for the peak of the season. And also they're calling for a little bit warmer than normal tropical Atlantic. So if this were the case, I think the Climate Forecast System model overall would yield conditions that are even more conducive for an above normal Atlantic hurricane season. So in addition to forecasting basin-wide numbers, we also do probabilities of landfall. Now, we can't unfortunately say months in advance when or where storms are going to strike. That's dictated by day-to-day weather patterns that you just don't have predictability on months in advance. But what we can say is that in general, more active seasons have more landfalling hurricanes. You can certainly point to counterexamples like 1992, where there was only one major hurricane all year. It just happened to be Hurricane Andrew, which obviously was a devastating hurricane in South Florida, came ashore as a Category 5. But in general, more active seasons have more landfalling hurricanes. Several great examples of that in recent years, 2017 and 2020. So we can see here the probabilities for 2022 are above normal because we are forecasting an above normal Atlantic hurricane season. So this year, a probability for, say, the number of major hurricanes, the probability for one or more major hurricanes is 70%, about 70%. The average is about 50%. You can see how those probabilities are elevated from both the East Coast, the Gulf Coast, and the Caribbean. And basically, we scaled those probabilities up, basically US-wide and as well as the Caribbean. There's not a lot we can say with which regions are more likely to get hit, although there is an area that we're actually working on right now. In addition to doing that for kind of these broad regions, we also do it for each state in each county and parish along the US coast, as well as for various islands and countries in the Caribbean and Central America. And the way that we do these probabilities is we count the number of storms, hurricanes, and major hurricanes that track within 50 miles of each county. And the reason why we do that is because you can, whether a storm makes landfall in your county or just very close to your county, and often is still going to provide significant impacts. So we use a 50-mile buffer to kind of smooth out some of the noise that you might otherwise get if you just looked at actual storms making landfall in your county. And so for example, Plymouth County, which the reason I selected that's because that's the county I grew up in, 10 hurricanes have tracked within 50 miles of Plymouth County. And this is looking from the years 1880 to 2020. So we can do these similar kinds of analyses for every county and parish, and then come up with probabilities for each county along the coastline. And these probabilities are available on our website, which I'll put up at the end. But we also do this for every state. So we have the probability of one or more hurricanes within 50 miles of all of these different states. We do it from every state from Texas to Maine, but here we focus on just a few states. Basically, for example, obviously, since we're focusing here on Florida, the probability on average, or the average probability of a hurricane within 50 miles of the state of Florida is about 56%. This year is elevated at 75%. And so, for example, we can think about 2020, no hurricanes actually made landfall in Florida, but Hurricane Sally, which made landfall in Alabama, was within 50 miles of the coast of Florida. So it would still verify as a hurricane being within 50 miles of the state of Florida. So our first forecast came out on the 7th of April. We'll update it on the 2nd of June. We'll put out another update on the 7th of July and a final update on the 4th of August. And even though obviously the July and August were already into the hurricane season, over 95% of all your major hurricane activity occurs after the 1st of August. So while hurricane season starts June 1st, often June and July tend to be very quiet. So we often really don't ramp up the season until August. So just because, for example, June and July say are very quiet this year, it wouldn't necessarily mean that the season was going to be a quiet season. So we do update these forecasts. And as you would expect, as we get closer to the events that we're trying to predict, the forecasts have more skill just because there's less uncertainty in things like El Nino and what the Atlantic is looking like. And so with that, I just wanted to briefly wrap up by talking about a website that our group at CSU put together with the Barcelona Supercomputing Center. With funding from AXA-XL. It's a website that has over 25 different groups that submit seasonal hurricane forecasts. So our group at CSU has been doing it the longest, but there's a whole pile of other groups, including NOAA, a whole pile of different universities and various government agencies as well. And so if you go to seasonalhurricanepredictions.org, here's what you'll currently see. These are the groups that have submitted their forecasts so far. So these groups are color-coded. Purples are government agents, purples are private sector weather companies. Blues are universities and reds are government agencies. The orange dot represents the average of all of the forecasts to date, while the red dot is the observed value to date. And so far, obviously, we've had no hurricanes in the Atlantic in 2022. So I invite you to check that out if you're interested in the seasonal hurricane predictions from a bunch of other different groups as well. And with that, I'd like to thank you very much, and I'll try to answer any questions.
Phil, thank you. That was very informative. We appreciate it.
Sure, thanks.
We got time for one or two questions. If anybody has one, we're going to time out in a few minutes. So if anybody has any questions, we have recorded this and we will put it on our website if we have this. So anybody have any questions? Phil, I guess not. Thank you. We really appreciate it.
Not a problem. Take care. Thank you. Bye-bye.
Bye.